Hello everyone, welcome to Mechanical Sati. So this is the second lecture in engineering mechanics. So already we have uploaded one video on this. So in the previous video we have discussed some introduction to mechanics basically. So we first discussed what your mechanics means. Okay. So what are different kind of study in mechanics like statics, kinematics, and your what that is dynamics. So in case of your statics, basically we are dealing with any body which may be remaining in rest actually, and in case of your kinetics your body will be at the motion state. Then in case of your again kinetics, it is being divided into two important parts. One is your kinematics, another is your dynamics. So in case of your kinematics, we are dealing with what is the how is your body is going to move. Like we'll be dealing with different velocity and acceleration, and but without considering what are the region of movement. Okay, so we need not to worry about the region of movement. We are not considering the different type of forces in this case of kinematics, but in this case of dynamics we'll be considering the region of movement. Like we need to consider the forces in case of your dynamics. After that we try to learn what a rigid body means. Then after we'll have learned how many type of forces are there, like what is a tensile force, another what is a compressive force. Then we try to learn how many types of loads are there. So we learn that there may be a point load or concentrated load, or after that there may be any uniformly distributed load, or there may be any uniformly varying load. So up to this we have learned in the previous class. So if you have not seen that video, then do find it from the playlist of engineering mechanics, or else I will attach the that link in the description box of this video, so you can find it from here also. So today we'll be discussing something more, so let us move forward and start our discussion. Another thing we discussed in the last video, that what a force means and how to define a force. That we have seen for defining any force we need to know the magnitude. Okay, and what is the direction of that force, and another thing, what is the line of action of that force. So let us see what we mean by the line of action. So line of action of a force means what? So the direction of a force is the direction along a straight line through its point of application in which the force tends to move a body when it is being applied. So this is the line of action. It is called as line of action. Suppose this is any body and we are applying force in this direction. Okay, so due to that what will happen? So this body will tend to move in this direction. So we can say this is the line of action of this force. Okay, so in which direction your body will be tending to move, then that direction we can say. Okay, or that line along along which line it is going to move, that line we can say this is the line of action. Okay, so now what we'll be doing, we'll be going to represent that is the representation of force. So to represent any force okay, graphically, so what we need to do, so let this is any body and 1 kilonewton of force is being applied in this direction. Then in at which angle it is being inclined, or okay, inclined to any x direction or y direction in 2D view, we can mention that angle. That's how we can represent any force. So graphically a force may be represented by the segment of a straight line. So basically any force is being represented by a straight line with it will be having with a direction actually. So straight line it will be consisting of a direction. So a force may be defined as like this, because this is a vector quantity, it should be represented by like this. Okay, what is the resultant of any forces? Okay, so suppose there are a number of forces. Okay, so let there are three forces and we need to find out the equivalent one force. So let it is given 5 Newton and this is 2 Newton and this is 10 Newton. Okay, and we need to find out the value of resultant, means what are the net effect of all these three forces. So that is known as your composition of forces. So here we need to study about the composition of two forces actually. So composition two forces means let there are two forces acting, and these two forces having different magnitude as well as different direction. Then we need to find out the effect of these forces, and we need to combine these forces and we need to calculate the resultant one. Okay, so let this is the resultant, and we don't know where will be your resultant lie. So let us try to calculate that. That means how we can find out the net effect of any two forces actually. So the reduction of a given system of forces to a simplest system that will be its equivalent, it is called the problem of composition of forces. So there will be number of forces. So basically here we have considered there will be two number of forces, and we need to find out the equivalent force which will be represented by one force, and that is called as your problem of composition of forces. So first there is a law, that is parallelogram law. Okay, that we need to study how to what draw the equivalent force. Okay, so that is known as your composition of force. So what a parallelogram law says. Okay, suppose there is any force, let this is a p force and this is a q force. Okay, so according to parallelogram law, so this force will be having, suppose this is the magnitude, that is p, and this is the magnitude of this force, that is q. Okay, and they are placed at an angle, suppose this is theta. Okay, and they're coming from a single point. Okay, so from this point it is going in this direction, and again from same point it is going in this direction. So they are coming from a single point and they are at some angle, that is theta. Then in this case, what a parallelogram law states, that equivalent force, or we can say that is resultant, will lie in the, by taking these two what these two forces as the sides of any parallelogram. So let me change the ink so that you can understand it better. Okay, okay, so okay, so by taking these two vectors, that is p and q, by any sides of a parallelogram. So try to draw the parallelogram over here. Okay, so let this is so let this point is o, then this point will be o dash. Okay, and this is a and this is p, this value is p and this value will be q, so that this value will be also, okay, let me erase something over here. Okay, so this value will be also p and this value will be also q. Okay, so this vector we have drawn over here. Okay, so this value will be equal to this value and this value will be equal to this value. So simply we have constructed a parallelogram by taking these two sides, that is p and q. Then what the diagonal will be getting over here, so that is o dash that is a diagonal. Then this diagonal will be represented as the what, that is the your resultant of these two vectors. So according to parallelogram law, so what are the conditions basically? if the two forces will be coming from a single point. Okay, so this type of forces we can call as the concurrent force. So we'll discuss later about two different types of forces, that is concurrent force, collinear force. Okay, here condition is that if two forces are concurrent, that means they are coming from a single point and with having different direction, and in between them there will be some angle and with some different magnitude. Then what we need to do, we need to construct a that parallelogram by taking the equal magnitude of these two forces. Then what the diagonal will be getting in this case, that diagonal will be represented as the what, that is the resultant of that two forces. So let us read the statement over here. So if two forces represented by vectors AB and AC, so these are two vectors. Let this is vector A and B, and again this is another vector A and C, acting under an angle alpha. So there is angle let alpha and are applied to a body at a point. Okay, so let this is any body at a single point, it is being applied. So AB is applied in this direction and AC is being applied in this direction. So their action is equivalent to the action of one force. That means it will be acting at a single point represented by the vector AD. Okay, so it is being single point. Okay, and their equivalent force that okay, so here equivalent force that will be represented by AD. So let this is AD. Okay, obtained as the diagonal of the parallelogram. Okay, constructed on vectors AB and AC. Okay, so this AD will be what? This will be the diagonal of the parallelogram, which will be constructed by using these two vectors, that is AB and AC. So now I think you have understood the concept of parallelogram law. So let us see the diagram and try to understand it very carefully. So here we can see whatever diagram we have drawn, that is being drawn over here. So this is the body what we have considered, and this is the AB force and this is the AC force, and the diagonal which will be considering from this parallelogram. So that will be represented by the resultant. Okay, so this will be represented by the resultant. Okay, so this will be represented by the resultant of these two forces. So which will be the diagonal of this parallelogram. Let me change the ink again. Okay, so if we'll be trying to draw the triangle and try to locate the angles over here, then from this we can draw this triangle, that is ACD. So this triangle I can draw. Okay, as this total angle was your alpha, so this angle will be also alpha. So I can represent it by this angle. This will be your alpha, and uh, when we'll be getting this angle as alpha, then this angle will be your 180 minus alpha. Okay, so let us move towards next and try to read something extra, and we'll be trying to calculate what the value of this AD. So we know the magnitude of this one and this one. So if we'll be knowing the magnitude of these two forces, that is SC and AB, then how can we calculate the value of this one? Let this is P and this is Q, or we'll be having some constant magnitude, any constant value. Then we need to calculate the value of this resultant force. Okay, that is 80. So let us try to calculate that. For that reason, we need to construct something, and let us first do that. So see here, force AD is the called resultant of AB and SC, and the forces are called the components. So here, what diagram we have already considered or constructed previously. So that is again here represented like this. So this is in the AB force, and this is the AC force, and the angle in between them here was alpha. Okay, so this will be the resultant force, that is R, or in the previous case we are getting as AD. Okay, so this value or this R value we need to calculate. How can we calculate this value? So let us see this. Then how can we calculate that? So okay, so let this angle is beta and this angle is gamma. Okay, so if we'll be getting the what that is your triangle over here. So let us try to reconstruct this triangle over here. So we can get this value, that is R. Okay, so this magnitude we need to calculate. That means we need to calculate the value of R, and this is the P. We have constructed this line over here. So this line will be constructing here, that is P, and again this is the value which is parallel to this one, means the magnitude of this force will be equal to this one. So this will be again Q. Okay, so we'll have considered this triangle over here. Then if you see, this angle will be given by this angle which is beta. Again this angle will be what? This is gamma. How? Let us try to find out that. So these are two parallel lines. You can see these are two parallel lines, and this line one of the intersection line which is intersecting both these two lines. Then we can see this angle will be equal to this angle. Okay, I think you can understand, or let me try again. So these are two parallel lines. Okay, again if we'll see, this is the line, this resultant line which is intersecting both the lines, that is this one and this one. Then for this we can find out this angle will be equal to this angle. So that's how we can say that this angle will be equal to gamma. So this angle we can find out, this is equal to gamma. Okay, so after finding out these two angles, this angle can be also found out. So this angle will be equal to how much? That will be equal to what? 180 degree minus what, that is that is, sorry, beta, plus gamma. And we know the value of beta plus gamma is equal to alpha, because alpha is being divided into beta plus gamma. So we can write it, that is 180 minus alpha, that is I have written here, that is pi minus alpha. So all these angles I have calculated over here, that is this angle will be your beta, this angle will be your gamma, and this is your what, that is pi minus alpha. So we know these values, that is p, q, and we need to calculate this value, that is r. So these two components are known to us. We need to find out the resultant of ab and sc, that is the value of r. So let us try to calculate that. So for getting the value of r, let us move to previous figure which we have drawn. So let us move to this figure over here. So we have drawn this figure from this one. Okay, so this you can say this is p and this is q. So this will be also p and this will be q. Okay, so here we can write this will be your p and this will be q and this will be r. Okay, so these are the two components which is known for us, and we need to calculate the value of r in terms of p and q. So we need to calculate the value of r in terms of p and q. So let us try to find out that. So let us find out that. Let us move to this figure and try to calculate that. So here we got to know that this is p and this is q and this is r, where we need to calculate the value of r. Okay, so let us construct a line like this. So let this is the point e. Okay, let this is the point e, and this is 90 degree, we can say. Let us draw a normal. So this was p and this was q and this was r. We need to calculate. So all these are the vectors and these are the magnitude which is given. So if we'll see in this triangle, so in this triangle, let me draw using another ink so that you can see it clearly. Okay, so Okay, so in this triangle which I am showing over here, so that is ADE, so ADE triangle. Okay, so we need to consider this value. Okay, so here if we'll be trying to calculate the value of R, so let me change the ink. Okay, okay, so if we'll be trying to calculate the value of R using this triangle. Okay, so that is by using this triangle ADE, then we can calculate by using the Pythagoras theorem, that we can write R will be equal to what? The value of this square, that is DE square and AE square. So I can write that uh, square of AE square plus DE square under root. Okay. So under root of these values will give me the value of R. So if I can calculate the value of these two sides of this triangle, then I can calculate the value of R. So let us try to calculate that. So this is the triangle, that is E. Okay. So now let us consider this triangle. Okay, that is in triangle CDE. This value we know that is P and this is Q and this value is R. We need to calculate the value of R. Okay, so in triangle CDE we can see that the value of your sine alpha. Okay, so if we'll be calculating the value of sine alpha, then I can write this will be equal to what? This is DE. Okay, DE divided by this P. Okay, so then from here I can write DE will be equal to what? So DE will be equal to P sine alpha. So DE will be calculated as P sine alpha. Next thing we need to calculate the value of AE. So now we have calculated value of that is DE, and that will be equal to P sine alpha. Then we need to calculate the value of AE. So AE we need to calculate, this value is P and this is R and this is Q. Okay, so up to this much is Q, and if we can find out this value, so we know that AE will be equal to what? That is AC plus CE. Okay, so this is given as Q, and if you can calculate the value of this one, then we can calculate this total, that is AE. So next again consider this triangle, that is triangle CDE. Then if we will be taking the cos alpha, then cos alpha can be written as CE divided by P. Okay, so here CE can be calculated as, so CE can be calculated as P cos alpha. Okay, so DE we have already calculated, that is your P sin alpha, and the CE now we calculate it, that is P cos alpha. So now let us put all these values in the A. Okay, so A can be written as, so A we can write that will be equal to Q plus P cos alpha, and DE we have already calculated, that is equal to what? That is your P sin alpha. Okay, so already we have calculated the value of R in this form, in the equation, in the form of this equation, that is equal to what? AE square, okay, plus that is DE square whole under root. So now let us put these values of A in this equation and these values of DE in this equation. So let us try to put that. So for that reason, let me erase some portions over here. What we know, that the value of A, that R will be equal to what? That will be equal to this square, okay, square of A and square of DE. So this is E. Okay, the square of A and the square of E whole under root. Okay, so AE we have already calculated. You can see in the previous equation that AE we have calculated, that is equal to Q. Okay, so I am writing it. that is q plus p cos alpha. Okay, so this is cos alpha rho, okay, whole square plus p sin alpha, okay, whole square, okay, whole under root. Okay, so now I can open this one. So a plus b whole square I can put, so I can write, so r will be equal to what? So r I can write q square plus p square cos square alpha plus 2pq cos alpha. Okay, so from this expression I can write down this one, that is q square plus p square cos square alpha plus 2pq cos alpha plus this one I can write, that is p square sin square alpha. Okay, so now I can take a common from these two, that is p square cos square alpha and p square sin square alpha. So I can take common p square, so let me erase this one. So if I'm taking common that r I can write, that is q square, okay, q square and plus, if I'll be taking p square common, then I can write cos square alpha plus sin square alpha. So I am writing cos square alpha plus sin square alpha, okay, plus what is remaining, that is 2pq cos alpha. So this is under whole root. Okay, so here it will be also whole under root. Okay, so now let me erase this portion. So here we can see your cos square alpha and sin square alpha, if we'll be adding these two, then we'll be getting 1. So r, if we'll be calculate, then we can calculate it as what, p square plus q square plus 2pq cos alpha. Okay, so under root. So r can be calculated as by this formula. So resultant value for parallelogram law, so that will be equal to this one, that will be p square plus q square plus 2pq cos alpha whole under root. So likewise we can calculate, or else we can calculate by using this actually. So we can apply triangle law to calculate the value of r. Okay, so directly we can put the value of triangle law. So what is a triangle law? We can say that triangle law is what, that sides of any triangle and sine of that opposite triangle, if we'll be dividing these two, then it will be equal for any sides. So we'll be taking these sides. Let I'm taking this side, that is p, and opposite of this side it will be equal to gamma. So p by sine gamma, that will be equal to q by sine beta, and that will be again equal to r by pi minus alpha. So this is the sine law. You can remember this one by taking this also. We'll be going to solve a number of numericals. So from, if these two angle will be also given, so if this single angle will be given, then we can put that formula which we derived now, that r will be equal to what, that is p square plus q square plus 2pq cos alpha. So this if this single angle is given, then we can put this formula, and if these two angles are also given, that is beta and gamma, then we can put the sine law, and we can find out to the value of resultant or any other forces also. Suppose in this equation, suppose these three angles or two angles are given. So if beta gamma is given, then we can find out the value of alpha. Suppose these two angles are given, and this resultant is given, and one of these two forces is given, then by putting in this equation also we can find out the value of what, other force. Okay, so now let us discuss some different cases where we have to change, or directly we can get the values. Okay, so one special case, if we'll be considering if you will be considering alpha equal to 0. So if we'll be considering alpha equal to 0, then we can say that let this is the p. Okay, and again in this direction also your q is lying, means both the forces. So let they are going from this point, this single point, this is o. Okay, so let this is o. Okay, so from this o, p is acting, so different magnitudes. So in this case there are with different magnitude, but direction is same. Okay, so there are the forces are with different magnitude, but direction is same. So in this case, what is the formula? So we can put that relation in this formula. So we can see over here. Okay, so r equal to what? P square plus q square plus 2pq cos theta, and theta is will be 0 here, or alpha taking, so alpha is equal to 0 over here, and cos 0 we know that is equal to 1. So I can write that is equal to p square plus q square plus 2pq. So and this I can write as p plus q whole square, and it is under root. So whole square and the under root can be cancelled, so though I can write it as p plus q. Okay, so if these two forces are acting in a same direction, then we can write the resultant will be added. Okay, so if these two forces are in same direction, then the resultant will be added. Okay, then let us try another case where alpha is 180. So in this case, if we will be seeing, then your forces are acting in opposite direction. So here we know this is alpha equal to 180, so this is the angle alpha. Okay, so this is 180. So let p is acting in this direction, q is acting in this direction, then what will the value of a resultant? So let us try to find out that. Again we will be putting these values. Okay, so that will be equal to what? P square plus q square plus 2pq cos theta or alpha whole under root. Then here 180 cos 180, we know this value equal to -1. Then we'll be getting that is p square plus q square minus 2pq. Then we can get this is p minus q whole square whole under root. Then we'll be getting p minus q. So if the angle in between these two forces is 180, means they are opposite to each other, means they will be having different magnitude, but with opposite direction, then we can calculate the value of resultant by deducting from the higher value to lower value. Okay, so p minus q. So here we have p in this direction, positive x. Okay, and q in the negative x direction. So we can calculate the resultant force by calculating this one. Okay, so that will be equal to p minus q. So let us move towards next and try to something discuss another case. Okay, so it will be having alpha is 90 degree, means they are perpendicular to each other. So if we'll be seeing here, the p is in this direction and q is perpendicular to p, so that means this angle is 90 degree. Then what will be the condition and what will be the resultant? So let us again put in this equation and we'll be trying to find out. So here p square plus q square plus 2pq cos theta, and theta, or sorry, alpha is equal to 90 degree, and cos 90 degree we know this is equal to 0, so this total term will be cancelled. So we can write this is equal to p square plus q square whole under root. Okay, and if we'll be trying to calculate the value of alpha over here, then I can calculate. So I can represent this q by this side, then we can calculate tan alpha will be equal to, so this is q and this is p. Okay, and we can write tan alpha will be equal to what? There is q by p. Okay, so alpha can be calculated. If alpha will be not given, then that will be equal to tan inverse q by p. Okay, so if it is 90 degree, so that angle in between these two forces, that is p and q, it is 90 degree, then it will be that the resultant force that will be equal to what? That will be under p square plus v q square. So in the composition of force, what we did that by taking two or more forces, and we have combined it, and we are getting a single force. So that was known as your composition of forces. So how to resolve means, so resolution means what? The replacement of a single force by a several components, which is will be equivalent in the action to the given force of is called a resolution force. So basically, if any single force will be given and we need to divide it in another two forces, then that condition is known as your resolution of force. So how can we do that? So let this is the R which is given, and this is the resultant force. So resultant will be given, and we can calculate the what the components of for these two forces. So if we'll be taking along the x-axis or y-axis, so we can find out that. So in this case, what we have done by taking this, if we'll be considering or drawing any parallelogram, then these two sides will be representing the component of this resultant. Okay, so whatever sides will be taking, so let uh, okay, so let this is R, and we can get a number of components from this force. Okay, so let I am taking, let me change the color. So I can get a something a relation components like this. Okay, or I may get components like this, or I may get components like this. I may get components like this. Okay, so a number of components we can find for this resultant R. Okay, so let us try to calculate in x or y direction. So let this is the force, or it is given that is F, and it is at the theta angle to the horizontal. Let this is the x-axis and this is y-axis. Okay. So what is the effect of this force along x-axis, that we need to calculate. So when your concern that the corresponding angle is given with any axis, then by taking this angle, we need to take the cos component of that. So what we can calculate? So if we'll be trying to calculate the value of fx, then that we can calculate by using this formula, that is f cos theta. Okay, so corresponding angle, if it is given, then it will be calculated by using this cos component. So fx will be equal to f cos theta, but corresponding angle, if it is not given, then we can use the sine component. So for example, let us consider force along the y direction. So now we have to calculate fy. Then how can we calculate? So that can be calculated by f sine theta. Okay, so fy we can calculate it by f sine theta, and fx you can be calculated as f cos theta, because it is your corresponding angle to x is given, that is theta. Suppose here this angle it is given as alpha. So now we can calculate fy equal to what? F cos alpha. Okay, and here again we can calculate fx, that will be equal to what? F sine alpha. Okay, so I think you can understand this one. So with this we have reached at the end of lecture for today. So in the next lecture we'll be continuing from this, and we'll discuss some more concepts, and then after we'll be trying to solve some numericals from this concept, whatever we learned till now. So this concept will be more clearer whenever we'll be solving any numericals. So if you like these videos, then press on the like button which is given below, and if you are new here, then do subscribe it and press on the bell icon, so that you'll be getting all the notifications from our channel whenever we'll be uploading any new video on this. So take care, bye bye, and thank you for watching.